Alright, hey guys, today is Wednesday, May 6th. This is going to deal with trigonometry and regular polygons. And so the idea here is they kind of give you the information you need on page 609. It says, recall that the central angles being congruent measure 360 divided by, basically to find a central angle, you take 360 and divide it by the number of actual sides in the polygon. So for the pentagon there, they do on page 609, they do 360 divided by 5, and so that will give you 72 degrees each. Since the radii are congruent, the triangles are isosceles. This means that each apothem bisects the central angles into two 36-degree angles. Also, it is perpendicular, and so this means we can focus on the right triangle formed. And so using trigonometry, basically, they do the algebra there, but basically, if the length of a side is known, the apothem is going to equal s divided by 2 tangent of 36, and the radius is going to equal s times 2 sine of 36. And so remember, to find reciprocal ratios on a calculator, you'll probably need to use the definition. So for instance, to find cotangent of 36, use the definition that cotangent is 1 over tangent, and then press the reciprocal button. So you can actually plug in the tangent, just do 1 over tangent, and you know cotangent. And so the example here on page 609, they give you find the apothem and radius of a regular polygon with a side length of 12, and so that is what they ask for. And so to find the apothem, you're going to do A equals, and it's going to be 12, which is the side length, the s, over 2 tangent of 36. So the side length over the 2 tangent of 36. So what this deals with is you can reduce that. The 2 and the 12 will cancel the 6. And then tangent of 36 would 1 over tangent of 36 would really be 6 cotangent of 36. So again, you can use the calculator at that point, or you could use the table in the back. Either way, you're going to end up with about 8.3. So 8.3 would be your apothem. Alright, to do the radius, again, it's going to be the side length, which is 12. So R equals the side length of 12 over this time 2 sine of 36. So again, the 2 and the 12 are going to cancel the 6. But then 1 over sine of 36 is really cosecant, and so it would be sine cosecant of 36. So 6 cosecant 36. And then that, if you plug it into the calculator or use the back of the book table, would be about 10.2. And again, on the calculator, you could just plug in 6 times and then 1 over the sine of 36, it would give you the same thing, or you can plug in the cosecant. So that's what that means. If you're using a calculator, you would just want to keep it as 6 parentheses 1 divided by sine of 36. And that would give you the same answer, because 1 over sine of 36 is cosecant. So the calculator, that would be how you would want to put it in, 1 divided by the sine. Alright, so that's pretty much all you're doing with that. So for example, if you look at number 1 on your, they give you example 2 there on page 610 with the circle. I won't do that, but all you do there is, again, you're just finding s now, and so you're just solving it for the different things. So just look at me real quick, just to make sure we get that. On example 2, it's at the top of page 610. Notice that they give you the radius, and so all you're trying to find is the length of the side of the inscribed regular polygon. And so they set the 10 equal to the formula, the radius formula, and then multiply both sides by 2 sine 36. That's all you do. And so, depending on what you're looking for, you just plug into the formula a little bit differently. It's the same formula. Alright, so look at 1 through 4. It says, refer to the regular polygon to the right, to the right. And so number 1, they want you to find the measurement of CPD. So notice CPD is going to be a central angle. And so to find a central angle, what you're going to do is take the number of basically sides and divide that by 360 by that. So for a pentagon, there are 5 sides, and so you would do 360 divided by 5. Then notice they give you CPM. CPM is just bisecting that central angle, and so you would just cut whatever answer you get in half, and that would give you the second part of that. All right, number 2 is PCM. So PCM is going to be the bottom of that triangle there. And so you need to know that the sum of the angles, this is dealing with an interior angle. So notice basically what you have, PCM is basically this part of the figure. It's basically that part of the diagram. And notice it's been bisected, cut in half. And so this plus this angle right here that you're looking at, plus this other angle on the other side of it, are going to add up to the entire angle. And so this is just another rule you need to remember. The sum of angles is the number of sides, the sum of the interior angles is the number of sides. So it's n minus 2 times 180. So you need to use that. This is just going back into previous lessons. So n minus 2 times 180 gives you the interior angle. And so if there are 5 sides, you would do 5 minus 2 times 180, and that would give you what the big one is. That would give you the big one, okay? And then to find the one we're actually looking for, you would just cut that in half. And so it'd be whatever that is divided through. So it'd be this, and then you would have to divide by the number of sides and then work it through. So I'll go ahead and do number 2 for you, since I've already worked it mostly. So I would do 5 minus 2 times 180, and then that would be 3 times 180. So what that tells me is that the sum of all the interior angles is 540. So that's the sum of all the interior angles. So then to figure out what one interior angle is, you would just do 540 divided by 5, so there were 5 of them. And then that would give you 108. So that would tell me that this big angle here on the pentagram is going to be 108. So that tells me that that big thing is 108. I just want to know what this small one is though. So I just do 108 divided by 2. And then that'll give me 54. So 54 would be the answer. That'll be that small one. Number 3, you're going to use bisecting to form a right angle. So you're going to use your trig there. And so again, they're looking for PM and what other one there? Just PM and PD. So you're going to set up your trig function. So we already found the 54. So then you're going to figure out, so for example, PM. I'll help get started there too. So this will be number 3. So PM bisects CD, forming a right angle with CM equal 3 by exercise 1. And so this would be, basically you're going to set it up as tangent 36, which we got in exercise 1, equals 3 over PM. That'll help you solve the first one. Again, in the first, number 1, we got CPM was 36. So that's why I'm using 36. And then to find that missing side, that's going to be the opposite over adjacent. So that's why I use tangent. And so that'll get you started for that one. To find PD, is going to be, you're going to be using sine. So it'd be sine of 36 equals 3 over PC. Again, the sine there is going to be opposite over hypotenuse, and so that's why I'm going to use the sine. And so that'll get you started with those. Again, just look at it and figure it through. Number 4 is the area of the pentagon. And so number 4, you're going to have to use this one. You're going to have to use, remember our area formula, which is 1/2 times the apothem times the perimeter. The perimeter was n times s, number of sides times the length of the side. And so you have to be able to use that. So basically for this lesson, I'm not going to go through it explicitly because this is a good review lesson to see what you actually remember. And so if you have any questions as you work through it, it'd be better to do it where I help you in class normally. And so if you have any questions, you can get up with me. Simply because it's not going to do much good for me to go back and work all these out. It's just going to be basically to see what you can remember and see what we can go through with it. I'll give you a few little hints. So 5, it says to measure the central angle, and we're using a decagon. So decagon is a 10-sided figure, and so for number 5, you're going to want to do 360 divided by the number of sides, and then if it's a bisected angle, and then the bisected angle, you're going to cut that in half. Number 6 is the apothem, and it wants the apothem in terms of the side. And so the side we don't know, so you're just going to use an S for that, but you're just going to use the formula. And so the apothem, half of the side, and a radius form a right angle. And so you can set that up as tangent of 18 equals, and try to figure it through. Again, just try to do the algebra. Number 7 is sine of 7. They're wanting you to do the radius in terms of the side. And so again, 6 and 7, they're just wanting you to come up with the formula like they did on the front. So you're just going to have to work it through with try to come up with the general formula. And then number 8 is where you're actually going to plug in to the formula. And so I'm going to go ahead, I'll go ahead and do 6 and 7 just to make sure we have those. Actually, I'm not even going to have you do 6 and 7. I'll just give you the answer. That way it'll make it a little bit easier for you. So 6 and 7 you don't have to do. So A would equal S over 2, cotangent of 18. So that is what you're going to have to use for 8, 9, and so on. And then, so that's 6. 7 is going to be R equals S over 2 times cosecant of 18. Now what you may want to do is go ahead and see if you can do the problem. That's going to be the answer. See if you can actually work it and then check and see if you can get there. Because this is what you should wind up with. And so you're going to set those 2 answers to do 9 and 10. So that's 6 and 7. So you'll use those. So you use 8, 9, and 10. Number 11, I'll go ahead and give you the answer to that too. And again, you can do the same thing. You can try to check the work and try to get down to that. But I'll go ahead and give you the answer just to make it a little bit simpler on y'all. So A would equal S over 2. Cotangent of 22.5, and then R would equal R would equal S over 2 cosecant of 22.5. And so again, you'll use that to do number 12 and 13 as well. I'll do, what did I give y'all? Just through 14. And so that will help y'all out, hopefully. Again, for 6, 7, 11, that's going to be your answers. You can actually try to do the formula to derive that if you want, but I'm not so worried, since we're doing this weird, I'm not so worried with y'all being able to derive it, but being able to use it. And so if you can derive it, that's good. If not, just use the answers that I give you, and then basically you're just plugging in S and working it through to find the answers. So that'll be pretty much today's lesson. Again, it's a little bit more difficult to teach it without you in here, so if you have any questions, get up with me, and I can help you out going through each problem. That would be a little bit easier to do, because I can point you directly to the issue with each problem instead of trying to do the overlay of each problem. And so, again, any questions, get up with me, but that's the lesson. And so it is 1 through 14 on page 610, 611. So any questions, that'll be that. So hope y'all have a good day, and again, can't belabor the point, but if you have questions, get up with me. I can help you. All right, y'all be good.